I actually am going to go through the steps of solving this one. I'm trying to isolate my variable. So my variable is attached to that 3. I need to take this plus 5, opposite operation is subtraction. I need to move that over here, subtract it over. We subtract the 5 over, 3x is going to equal the 14 minus 5, or 9. Since the x is attached to the 3 through multiplication, the opposite operation of multiplication is division, so I divide by 3 to move the 3 to the other side. Divide that 3 into that 9, x equals 3. And then what we're supposed to understand about getting solutions to equations is whatever I get here as my answer, I could take that x, I could go back to the original equation, I could plug back in for that x to check and make sure that it actually works. Assuming I solve correctly, it will. All right, we're going to get wild and crazy on this one. We're going to put the x on the other side. X on the other side. Beware, it is minus 4x, so understand it is negative 4x is the term. This 22 right here, I need to move over here. To move that, since this is positive, I'm subtracting, right? Now, we kind of talked about this in our side session on the last problem. I can write that step, minus 22, you know, under each of these if I want. Here's the column approach, if we like that way. But really, if I know how to take 5 minus 22, negative 17, that's all I need to write on that side. That equals the negative 4x. Paying attention to the negatives here once again. Now divide by the negative 4 because that's what's multiplied to the x. I said we were getting wild and crazy here. Got some negatives that are being divided, so that's positive. 4 does not go evenly into 17. So as far as I'm concerned, let's leave this answer as exact as possible. We'll leave it in a fraction form. If necessary, reduce. Just leave it as 17 fourths. And we'll let that equal x. There's our answer. So we've had two equations where, you know, we can just kind of dive right in and start moving stuff from one side to the other. But really, when you solve an equation, you got to make sure that each side is completely simplified before you start making those moves. I mean, you don't have to do that, it's just easier to do that. So you got a minus sign right here in front of the quantity that you probably would want to distribute through like so. That changes the signs, obviously, on the terms inside. And if you collect your like terms now on the left side of the equation, you've got 3 basically minus 2, 3, plus that 3p as your simplified expression. That's going to equal the 10 over here. And this is what we do in algebra. We continue to try to turn things into stuff we already know how to play with. And right back where I was at on the previous problems, take this 3 here, it's positive, subtract it over. 3p equals 10 minus 3, 7. Divide both sides by 3. Since 3 is multiplied to p, get 7 divided by 3, or 7/3. So if we're going to solve the equation, we've got to make sure each side is simplified. Over here we got some work we can do because we can take this negative 2 and distribute through. So I distribute the negative 2 through, I leave the 4x alone for just a moment. As the negative 2 goes through, it's negative 2 times 3x minus 6x. Negative 2 times positive 6, negative 12. That equals the 2x minus 1 over here. Collect some like terms. So 4x minus the 6x gives me negative 2x minus 12. That equals 2x minus 1 over here. So we haven't seen this situation yet, but we've got variables and constants on each side. It doesn't really matter which kind we move first, but normally I like to move the variables first. So I'm going to take this, since this is negative, and I can add it over here. I like to be positive, so I'm going to add the 2x over to this side. If you're really daring about this, at the same time I could take this minus 1, since I'm moving x's over here, I could take the minus 1, add 1 over here, right? In doing that, I've got 1 minus 12 on this side, negative 11. Over here you got 2x and 2x, 4x, divide by 4, x is negative 11/4. All right, so what do we do if division's involved or fractions are involved? Well, opposite operations are what move things. And there's a couple of ways we could approach this. But if I take care of the fact that really you're dividing by 5 here with that 2, you could multiply both sides by 5. And that would take care of the 5 that's on the left side in the first place in the denominator. You'd have 2x equals 50, and then you could just divide by 2. If you divide by 2, you get 25. Right, with the absolute value, we can branch out. We can go 2 directions. In one of those directions, whatever's inside the absolute value here, 2x minus 3, we could set that equal to basically the positive version of this number. Or we could take what's inside the absolute value and we could set it equal to the negative version of that number. So it's kind of like I write the same equation down twice, except what everything equals. One's positive version, one's negative version. I've got some linear equations to solve. So by now, we know how to shuffle things around. If I add this 3 over, I've got 2x equals, well, that'd be 14. Divide both sides by 2. Got 14 divided by 2, x equals 7. Whoa, I'm not writing out some of the steps now. I'm kind of doing this in my head, aren't I? Be careful. Over here, same operations. After all, it's the same expression that's inside the absolute value. If I add the 3 over, now I've got 2x equals negative 11 plus 3, get negative 8. Divide both sides by 2. X is, that's negative 8 divided by 2, so negative 4. So I have this answer, or I have this answer. Both should work if I plug back into the equation and check. If you have an example where something's attached to the absolute value, before we start branching off, we need to try to find a way to eliminate this attachment. So this is attached by multiplication. To move it, we divide it, right? If you divide it, you got the absolute value of 6x minus 1. That equals 18 divided by 2, so got 9 over here. Now we're back to something that's a little more familiar, like the last problem. Branch out. Got your 6x minus 1 from inside the absolute value. I'm setting that equal to 9. Or I've got my 6x minus 1. I'm setting that equal to negative 9. I solve this first equation here. I'm going to add my 1 over. Got 6x equals 10. Divide both sides by 6, and x is 10 divided by 6, right? So 10/6, if I leave it as the fraction in the improper form, that's okay. But I should reduce that. 10/6. I should reduce that to 5/3. Over here, add the 1 over. Got 6x equals negative 9 plus the 1, get negative 8. Got a similar kind of scenario here playing out. Got to divide both sides by 6, so it's negative 8 divided by 6. Negative 8/6 reduces to negative 4/3. So I've got this answer, or I have this answer.